I will try to get them from here. Hmm. You tell me your answers. You can see the screen.
Yes.
Okay, so you tell me the answers. Your side.
Okay. Number one, I gave A.
So give cross. The answer is C. Huh? You can see the MCQ part answer, right?
Yes, yes, yes.
And two you gave
I gave B.
C.
B, Bangladesh.
Two you gave B. So it is also cross.
C.
Then three.
C, I gave also B. Bangladesh.
It is also cross. Then four.
4, I gave A.
Correct. Five.
5 blank. I couldn't solve it.
Okay. Give the question mark. Which one you
Yes.
couldn't solve? You give the question mark.
Okay, sir.
And then six.
6, 6D.
Dhaka.
Yes.
Okay. Correct. That's seven.
7 also blank.
Blank.
Yes.
Question mark, please.
Okay.
Then eight.
8C.
Then nine.
9D Dhaka.
Mm-hmm. 10.
10C.
10C. Okay.
Yes.
Correct. Then 11.
11B Bangladesh.
Yeah. 12.
12A.
12A. Cross, huh?
Okay.
13.
13D Dhaka.
13D Dhaka. Okay. Correct. Then 14.
14 also D Dhaka.
Dhaka. Very good. So, how many you got wrong?
I got 3 wrong and 2 blank.
Okay. You got three wrong and two blank here. Um, so, one is wrong, right?
Yes.
One you gave
A.
A. The which quantities may be different. The beam balance is in equilibrium.
Yes.
So if they are balanced,
Yes.
then they are in equilibrium. We have the notes, that principle of moments, right?
Yes.
And the conditions for equilibrium.
Yes.
So conditions for equilibrium, we have two things. One is the forces should be equal,
Yes.
right?
Yes, sir.
And the moment should be equal. So B and D, these
Yes.
two are related to moments, and weight is also force. So B and D, they both are directly matching with the conditions, right?
Yes.
And mass, if you think, it is also indirectly related to D, the weights,
Yes.
because on a uh, on a same place on the earth, the gravitational field strength is same, right?
Yes.
So if the gravitational field strength is same, then the mass will be also same, right? For this
Yes. Yes, sir.
mass multiplied by gravitational field strength is weight. So
Yes.
masses of the two objects should be also same. What can be different? The volumes can be different
Yes.
because two objects with a different volume, they they might have the same mass, right?
Yes, sir.
So you can write this note beside your answer sheet. Two objects with the same volume, two objects with the different volume might have the same mass. What
Yes,
you
sir.
are
Done.
seeing, what you are seeing in the screen, your answer sheet,
No, sir.
that one
The
only
question.
the question is only, right?
Yes.
Okay, good. Now, which one you have problems after that?
Two
Two.
number. Two.
Question number two. Okay, let's see. Which object is in equilibrium? You chose
B.
Bangladesh.
Yes.
Look, if you are pushing it upwards from here and you are pushing it from left side downwards, then the turning effect they are creating is anti-clockwise, right?
Yes.
For both of them, we are getting anti-clockwise.
Yes.
So this way, we are not getting this one in equilibrium. Only in C, we are getting both them from opposite side, right?
Yes.
And directly perpendicular.
Mm.
Here we are getting in the corner, right?
Yes, sir.
So as we are getting at the corner, then they are not balanced. They are turning.
Mm.
But
Yes.
here we are getting in the middle.
Mm.
That's why they will be balanced, right? 2
Yes.
Newton and 2 Newton opposite side, they will be balanced. And they will be staying in equilibrium.
Yes.
So C is the correct answer. Huh?
Yes, sir.
Then which one? 3.
Yes. Number three.
Okay, 3. So here we got in which diagram is the turning effect greatest?
Mm.
As they are saying about the turning effect, we can consider they are talking about the moment, right?
Yes.
So how we calculate the moment? Uh, Force multiplied by the distance from the pivot, right?
Yes, sir.
Perpendicular distance from the pivot. So the
Yes.
pivot's position is there. Which
Yes.
one you chose?
I give B. Bangladesh.
You gave B.
Yes.
Okay, look here. Uh, we are having this one from pivot. The perpendicular distance is most, right, for both of them,
Yes.
and this one is anti-clockwise, and this one is also anti-clockwise. So we are getting here double moment of equal size working in the same direction.
Yes.
and here we are getting uh, half movement for this force and half movement and the double moments from here, right?
Yes.
So this moment for both f, if you calculate, it will be less than this one.
Yes.
So we can choose A, right? And these two we are having, one is clockwise, another one is anti-clockwise, right?
Yes.
This one, so they both are equal and they will be balanced, huh?
Mm.
Here also we are getting here, one is clockwise, another one is anti-clockwise, but this one is half. However, they are balanced,
Yes.
so they will be in equilibrium. This one will be equilibrium, but these two are not in equilibrium. They have the greatest moment in A, right?
Yes.
Then which one next?
Number 5.
Number five. Yeah, number five. Which one you chose?
Blank.
Okay, blank. About the pivot, the resultant moment we are going to find. In this case, we have to find the force and distance from the pivot.
Yes.
Now we have given the information for 5 Newton force. The distance from pivot is 15 centimeter,
Yes.
and this one is anti-clockwise. You see, if your force is going in this direction, that is going anti-clockwise, right?
Yes.
And for 10 Newton force, the distance is 10. Here it is
Yes.
15 and the total distance is 25. So from the pivot, the distance is 10.
Yes.
Are you writing on your copy? The one you are
Yes,
getting
sir.
correction, you should write.
Mm.
So we are having here distance 10 centimeter
Mm.
from the pivot, and it is clockwise. These two things you have to
Yes.
mention. And from here, the distance is clear. The moment is anti-clockwise.
Yes.
So the clockwise one we are getting 100, and
Mm.
anti-clockwise one we are getting 75. Then the resultant is 25, right?
Yes, sir.
And the resultant should be clockwise or anti-clockwise?
Clockwise.
Clockwise. Very good. So which option you choose?
B.
Bangladesh. Okay. Very good. You can see the screen, the mark screen.
No.
Okay, you are seeing the question only, right?
Yes.
Okay. You have five. The answer is B. Then which one next? Six.
7.
Six, you got correct. MashaAllah. That one is also tough one. Then seven. Seven is a very tough questions. Huh? One of the tough questions. And here we are using both conditions for equilibrium. We had two conditions for equilibrium, right?
Yes.
One is the forces should be balanced, and that means the opposite forces are balanced, and the uh, opposite moments are also balanced, right?
Yes.
Equal. So the first condition we have to check out that. what will be the value of force if we are trying to get this one equilibrium. They are saying what is the tension in a string Q, and there where it is attached so that the beam is in equilibrium. So our beam is in equilibrium, so we will make both the conditions for equilibrium. The first condition is the forces should be balanced, right? So here
Yes.
we are having downward force 6 Newton, upward force 2 Newton. And so the string they are saying Q, that string should be upwards, and it is 4 Newton to make all the forces balanced, right?
Yes.
Do you understand what I'm saying? Should I repeat? Hello, Abir,
Yes, sir.
you understood it? That downward force is 6 Newton, right? Abir,
Yes, sir.
hello. And the upward force is shown here 2 Newton. So we need more 4 Newton upwards to make the forces balanced, right?
Yes.
And that's why the string, they are saying string P is 30 centimeter from the left hand end of the beam as shown. String Q is not shown. So the string Q should have 4 Newton
Yes.
upwards. We will find it from the other condition, that is principle of moments. Anti-clockwise and clockwise moments should be equal. But that is 4 Newton. It's clear, right?
Yes.
It should be 4 Newton upwards. So we will now try to find where it is. 4, 4 Newton,
Yes.
where it should be staying. Now, here we are getting 6 Newton, and we have here 2 Newton, and the beam of weight 6 Newton is suspended from two ends P and Q. Okay, now uh, our uh, here we have 6 Newton multiplied by 20, right? So what is
Yes.
the moment coming? Here
120.
is the pivot, right? It is attached here.
Yes.
So here we are getting 120,
Yes.
and this one is clockwise.
Yes. Yes.
And the one which one is 2 Newton, it is upwards. We are having the distance 30 centimeter. That one is anti-clockwise. So how much it is? 60, right?
Yes. 60.
Yeah,
60.
60. Yeah, 60 Newton centimeter. So we need other 60 Newton centimeter, right? Anti-clockwise.
Yes.
So
Yes.
if you are trying to get 60, then that should have 4 multiplied by 15, right?
Yes.
And that will make 60. Now, if you are taking it from here, right? Then where it will come?
Yes.
Almost here, right? In the middle
Yes.
of 30 centimeter, right? So we can give here this one 4, right?
Yes.
4 newtons here. Our 4 Newton force is working here. So 4 Newton is 15 centimeter from the left end, right?
Yes.
So which option will be correct?
D.
Bangladesh.
Yes.
Got it.
Yes.
It is a difficult question, right?
Yes, sir.
However, it's making us to understand, analyze, and it's increasing our analytical ability, right?
Yes.
Okay, so we need this type of questions more and more, right? So that we can learn more. Okay, here
Yes, sir.
we can go next question, right?
Yes.
It is
Number
correct.
12. Yes.
Number 12. Number 12. Number 12. Yeah. uh, in which position is the moment greatest? Which position the moment will be greatest? We have to find, right?
Yes.
Uh, here, the person is holding the ladder, right?
Yes.
Holding the ladder on his shoulder here, isn't it?
Yes, sir.
For every position, it's his pivot. Huh? This one is
Yes.
the pivot. Position of the pivot is here. Now, from the pivot, we have to check out the distance. Here, from this position, if you observe carefully, then you'll see it's in the middle, right?
Yes.
So the weight working from the ladder in both the sides working this way, right?
Yes.
Here we are getting some weight, and here we are getting some weight. So both the weights are working
Yes.
uh, from the same distance. One is clockwise and other one is anti-clockwise. Both the moments are equal.
Yes.
So there is no resultant moment here for A. Okay, got it?
Yes, sir.
And for this position, you see, we are having the object here. Hmm. In this position, we have some weight here, and we have some weight here in the opposite side, right? Turning effect
Yes.
will work. There will be some resultant moment, but we are understanding that there will be resultant moment, but the difference in resultant moment is not that much, right? There will be resultant moment, but
Yes, sir.
the difference will be not that much. And in this position also, if you see the pivot here, there will be resultant moment clockwise and anti-clockwise, but it's not that much.
Okay.
But here in this position, if you consider this one is the pivot, so the right side we have a bigger weight, right? The weight is very
Yes,
big.
sir.
The force is very big. So clockwise moment is very big, and
Yes.
anti-clockwise moment is not that much. So this one will give you the greatest moment. Is it clear?
Yes, sir.
12 is done. Then which one is next?
All done.
All done.
Yes.
Okay, very good. Now we are going to your answers in structure part. So you correct all of them, huh? then you give me.
Yes,
Today you can take the test, right? After discussion, is it
yes, sir.
possible, or you will take in next class?
Next class better.
Okay, if you think that you need some more revisions, then we will discuss new topic today. That is deformation. And after discussing the new topic, deformation, we can go with the worksheet, right?
Yes,
I can give you the worksheet as homework, and you can take the test at the beginning of that class. And after your test, if you have some time, then we'll discuss the worksheet. Is it okay?
yes, sir.
Okay, now structured part. The weight you got 230 Newton. Mm, it is correct. And the moment you got 300 Newton meter, it is correct, right?
Yes, sir.
And you wrote moment at painter is greater than the moment at blank.
Movement of plank.
Okay, moment of painter is greater than from moment of blank. Yes, correct. It's correct. So you got this one easier, right?
Yes,
So the next one you gave the definition of what? Center of mass. It is center of mass, right? A point representing the main positions that matter in a body or system. A point representing the main positions of matter in a body or system. Okay, it's fine. And we can also say that the point where all the mass of the object seems to work together, right?
oh, yes,
Yeah. Uh, then the conditions for having more stability, less center of mass, you you change this wording, you make it there, uh, lowering the center of mass. That means it's going down, right? Not less.
okay, sir.
Lowering the center of mass. The center of mass should go down. Okay.
Yes, sir.
Uh, then we are having the third part. C. How to get the center of mass of a lamina, right? First at all, we
Yes,
can suspend the lamina next to plumb line. After that, mark or draw vertical line on lamina along the plumb line. Then we can do it again from next point to get the center of mass at the piece of card. Yeah. Then finally, you can add one thing here, that is we will check that both the lines where it is crossing, the intersection of the line is showing you the center of mass, right?
yes,
That one should come here because there are 3 marks. Your 2 points came. Another point is that one.
oh,
Yeah, by checking where the line intersects, that the intersecting point is giving us the center of mass of the lamina. Did you write?
yes, sir. Done.
Okay, very good. Now we have question 3. Yeah, 20 Newton, 14 Newton meter. 20. So here, what is the question there?
Calculate the weight.
Calculate the weight is fine, but the moment, question number three,
Yes.
when the lid is closed, right? Calculate the
Yes.
moment about the hinge when the lid is closed. So it is uh, hinge, right?
Yes.
And weight is working where? Where the weight is working, the lid is this one, right? Hello?
I cannot see the question, sir.
Okay, okay. I'm showing you, no problem. Thank you for your information. Here. So here is the weight, 20 Newton. That one is working in the middle, right?
Yes.
Middle of the lid. That's the thing we have to understand. So if it is in the middle, that means it is away from the pivot 0.35.
Sir, I have a question.
Sure.
How did you understand that the weight is in the middle?
Very good. I like your question. Thank you so much. Uh, we understand one thing, that the lead is uniform object, right?
Yes.
So for any uniform object, any kinds of uniform object, like this one is one uniform object. Everywhere it is same. The length, breadth are matching in both sides, right?
Yes.
And that's why it is uniform. And there might be one football,
Yes.
this way. It is also uniform, So the center of mass should be in the center, So for uniform objects, we can find the center of mass in the center of the object.
Oh.
But for non-uniform objects, the one we discussed, that plain lamina, that one you have to find out with that technique. The one you said, these 3 points. Now it is clear,
Yes, sir.
and I am really happy on you that you asked me these questions. If you ask questions, then you will improve. Then you are developing. Thank you so much. Now you get the moment, right?
Yes.
So what is the value of moment?
Moment is 14 Newton meter.
14.
Yes.
Still 14.
Yes.
If you multiply with 0.35 and 20 Newton, the distance you got 0.35.
Yes. Then it is 7.
Yes, so it is 7 Newton meter. You calculate it, again calculate
Yes,
it
sir.
and write the answer correctly. They are saying calculate the moment about the hinge when the lid is closed, right?
Yes, sir.
So we are getting here center of mass. The weight is working here. The distance from the pivot of this weight is 0.35. So 20 multiplied by 0.35. Is it clear?
Yes, sir.
Then we can go to next one, huh?
Yes.
Your next question is giving us mm, and the other part is correct. Friction at hinge, that one is correct. Uh, we have here one screwdriver, right?
Yes.
And you found the center of mass is working opposite of weight, right? The
Yes.
point where the weight is working, that is your center of mass. Very good. Then you have here B1 0.64 Newton. Let me check the mark screen. Yes, it is 0.64. Then arrow W vertically downwards to candidate C. Yes, very good. Hmm. And C, part C, no resultant force or upward force equals downward force. No resultant moment. Okay, okay, that one is principle of moment, right?
Mm.
They are asking you the principle of moment. Here the question is asking you what? The question is asking you, hmm, okay, okay, I understand. C, part C. Hmm,
Part.
hmm. There is no part C here given, only part B.
Yes.
Okay, fine. You are done, huh? This
Yes,
worksheet.
sir.
This worksheet is done. Now you analyze, huh? Your answers you analyze, and you resend me, huh?
Okay,
Resend
sir.
me it after correcting your worksheet. You resend me, huh? So that I can preserve it again with corrections. Is it okay?
Yes, sir.
Okay, very good. Now we have uh, we get a break now, huh? For 5:55 we'll start. Okay,
Okay, sir.
5:55 we will start. We have a break now. 5:55 we'll join inshallah. Okay.
Yes, sir.
By this time I'm uploading worksheet 6 and note 6.